This is a podcast on double replacement. So double replacement is when you have two compounds and two things switch. So the A and the C switch place or the B and the D switch place. You can choose however you want to look at it. But since A is first, it has to be first on that side. There are different types of double replacement. There's like a precipitation type and a neutralization type. And there are different driving forces for why a double replacement reaction would happen. So if on the right-hand side of the arrow a solid is created, which is also called a precipitate, the reaction will occur. If a liquid is created, for example, liquid water, the reaction will occur. And if a gas is created, for example, a diatomic gas or a gaseous water, which would be steam, the reaction will occur. So you don't always need to have a solid produced to have a double replacement reaction occur. And when you do most of these double replacement reactions, you need to use the solubility chart. And we'll get to the solubility chart in a minute. So let's take a look at the solubility chart. This is not all the soluble possibilities, but it is a list that will help you out. So soluble means aqueous, or AQ, means it will dissolve in water, or the two ions will break up and dissolve in water. Insoluble, which is represented by an S for solid, it means that something will not break up. It means it really is like a precipitate or it's still a solid. So for example, Na plus, if you have a compound and it breaks up into two ions, Na is soluble all the time. Potassium is soluble all the time. So is ammonium and nitrate and chlorate. You don't have to memorize these, but you may use this enough to remember that those ones are soluble all the time. But then we get to some exceptions. So chlorine is soluble almost all the time, unless it's with Ag, Hg, or Pb. For example, if you had AgCl, you would write it with an S for solid. And it continues down here. Let's keep going to the soluble one. So like the last one, this is acetate. So acetate is almost always soluble unless it's with silver. So silver acetate would be a solid. And then I wrote insoluble on these ones. So carbonate is insoluble most of the time. It's only soluble a little bit of the time with sodium, potassium, ammonium, or hydrogen, because that would be carbonic acid. So sodium carbonate is soluble. So if you had phosphate and it was connected with sodium, you had sodium phosphate, it would be soluble, but if you had like silver phosphate, it would be insoluble. So that's how you use the chart. So let's begin doing some reactions. Let's start with number 2 on worksheet 4 that has the double replacements. So number 2, I'm skipping number 1 for a reason, has lead nitrate, so PbNO3 plus Na2CO3, Na2CO3. I'm not going to have enough space on here. I'm going to have to write somewhere else. So you can tell it's a double replacement because you have a compound here and a compound there. And what could possibly happen, how I like to look at it, is Pb could possibly switch with Na. But what we have to do is find out if this is AQ and that's AQ. And we find out if lead nitrate is AQ by going down here. And there's nitrate. Nitrate is soluble all the time. So this one is AQ. You're really supposed to write it next to it, but I'm going to write underneath it. I'm running out of space. Now we look at sodium carbonate. Let's see if it's soluble. Sodium is soluble all the time, so that one's AQ. Whoa, that's a big AQ. So if you have an AQ, two AQs on the left-hand side, the reaction can proceed forward. Now we have to see if we will make something that is insoluble. We need to make an insoluble to actually have a reaction. So over here we could have lead carbonate and I believe that's what it ends up being. And we could make sodium nitrate. I'm going to squeeze this in here. And the reason is that the Na and the Pb switch places, and then I started over with charges, a +1, a -1, so it's a 1 to 1. And that was a -2, and this one was a +2. I could tell, since that was a 2, that that was a +2. So they are written correctly. Now I have to see if one of them's a solid. So lead carbonate. I don't see lead on here, but I see carbonate is insoluble, so it's a solid, unless it's with one of those. And lead is not one of those. So we do have our solid. Yay. So the reaction happens. So you could write solid, you could write PPT, or you could write a downward arrow because precipitates fall down. Now sodium nitrate is aqueous, and that's fine, because sodium is soluble all the time. And then you'd have to balance the reaction, and I think you need a 2 in front of that. And you're done. Let's try number 6. Number 6 is NaBr, so we got to check and see if it's aqueous. Well, Na is aqueous all the time. That's a lovely AQ. Plus, where is it? PbNO3, PbNO3, 2, and nitrates are aqueous all the time, so that one's aqueous. So the reaction could possibly happen. Let's see what we could make. The sodiums and the lead switch places, so I think I'll write the Pb and the Br first. Pb is a 2+, Br is a 1-, so I need 2 of those. And we could make NaNO3. I think we did this one, didn't we? Or we already had NaNO3. NaNO3, it should be really written that way, and it's 1 to 1. And that one's aqueous because NaNO3 is always soluble. Let's see about lead. Lead's not on there, but Br is. Br is soluble unless it's with lead. So that is a solid. So we get a reaction. Or you could write precipitate, or you could write a downward arrow, whatever floats your boat. And then we have to see if it's balanced. I think, again, we need a 2 in front of that, and possibly a 2 in front of this. Yep, and then it's balanced, and the reaction occurs. Let's try a neutralization reaction. I don't see one on that worksheet, so I'll make one up. So it's an acid and a base. So here's an acid, HCl, plus a base. Let's do KOH. Anything with OH in it is a base. So it's hydrochloric acid plus potassium hydroxide. And again, really just the K and the H switch places. So you end up with KCl because it's a 1 to 1 with the charges, plus HOH, which is actually water. So neutralization is an acid plus a base equals a salt plus water. Now salt doesn't necessarily mean table salt. And the reaction happens because you create liquid water. And I believe the whole thing is balanced. Let's do another acid base where it doesn't balance out quite as easily. So let's do an acid base that doesn't balance out quite as nicely. Let's do H2SO4 plus NaOH. So the Na and the H will switch places, so you'd end up with Na2SO4 plus H2O. Now again, you make liquid water, so the reaction happens, and there's your salt. I think you probably need a 2 in front of there. So you have 2 NAs and 2 NAs. You have 1 SO4, 1 SO4. We have 1, 2, 3, 4 H's. So I needed 2 over there to make it 4. And then I have 2 O's and 2 O's, and it balances. I'm going to do number 12 on the worksheet because the reaction actually doesn't occur in this one, but let's see why the reaction doesn't occur. So you have H2SO4 plus KCl. You got to check out if they're aqueous or not. That one's aqueous. Almost all acids are aqueous. And the K and the H would switch places, so you'd end up with K2SO4. We look and see if that is soluble or not. There's K. K is soluble all the time, so that's AQ. AQ plus the other item we would end up with is HCl. That's totally weird. Well, Cl is soluble all the time unless it's with one of those, so that would be aqueous. So that is a no reaction because you get no new products. Nothing new. You do get something new, but it's because they're all aqueous. You have to have a solid or precipitate for a reaction technically to happen. I'm going to recap what conditions you need to have a double replacement actually occur. So on the left-hand side, you need something that's aqueous plus something that's aqueous, and then on the right-hand side, you need at least one solid and one aqueous, and they don't have to be in that order. They don't have to be solid then aqueous. It could be aqueous then solid, but you have to have at least one solid on the right-hand side. You could also have two solids on the right-hand side, and the reaction will happen. So if you had two solids, the reaction would also happen. But if you had AQ, and it made an AQ and an AQ, that would be no reaction because you have to have at least a solid or a liquid or some type of gas created. And if on the right-hand side you have one solid or even two solids, the reaction won't occur. A reaction for these does not occur because it has to be able to dissolve in the aqueous solution. I hope this has helped you a little bit. I hope it hasn't confused you more than possible, and I will see you next time.